First, let's see how mechanical weathering occurs. If we take two pieces of rock, like these, what happens when we rub them together? One of the rocks breaks into pieces. Now, here, we have two more rocks. Again, through rubbing, the rocks crumble, one more than the other. This is because different types of rock have a different composition, and some break apart more easily than others. Such weathering, the breaking of rocks into smaller fragments, occurs everywhere on Earth's surface. Dramatic changes take place over millions of years, as mountains are worn down, valleys formed, or the course of rivers changed. Scientists call such changes mechanical weathering, when weathering occurs to natural forms and structures without changing their chemical composition.
Think for a moment. Where you live, what are some examples of mechanical weathering? Among the examples you might have given are cracked sidewalks, cracks in buildings, or potholes in roads. Wedges of ice often cause mechanical weathering in natural settings, as snow thaws on mountains in the sunlight, melting into cracks, and then freezing when the temperature falls at night. To understand what takes place, let's place a bottle of water in the freezing compartment of a refrigerator. What do you think will happen to the bottle?
Four or 5 hours later, the bottle has broken. Because as the water froze, it expanded, causing the glass container to crack. This is essentially the same process that occurs when ice cracks rocks and alters the face of mountains. In contrast to mechanical weathering, chemical weathering takes place when a rock's chemical composition is changed. For example, look at this piece of steel wool. Now, here it is several days later, after water and oxygen have changed the chemical composition of the steel wool, and the iron in the steel wool has turned into rust. Water is one of the main agents for chemical weathering. For example, certain minerals in rocks are dissolved when exposed to water. Then, when the water carries away the dissolved minerals, the remaining rock has a new chemical composition. The process of oxidation, the chemical reaction of oxygen with other substances, also causes chemical weathering. Oxidation, for instance, can change iron into rust, a common problem with steel structures like this bridge. Carbon dioxide in the air also mixes with water, forming carbonic acid, which can dissolve many minerals, such as calcite that's found in marble. Statues and buildings often show the effect of this kind of chemical weathering. For protection from chemical weathering, statues and structures are painted with special coated material which safeguards the metals from the harmful effects of water and oxygen. In another form of chemical weathering, acid chemicals produced by plants, like moss, can also break down rocks by dissolving certain minerals and making the rocks weaker. Over thousands of years, carbonic acid forming from the air and water can dissolve limestone bedrock underground, hollowing out caverns like this one.
Climate plays an important part in weathering. In a desert with low humidity, the rate of weathering is slow. But in places with warm temperatures and high humidity, such as rainforests like this, rapid weathering occurs. And where temperatures vary constantly and freezing and thawing occur often, we see the evidence of weathering everywhere. Weathering, however, can also have a positive effect on our lives. The soil used by this gardener, for example, is the result of weathering. As rocks weather into smaller pieces, tiny plants grow on the particles. And as worms, bacteria, and fungi begin to live around the roots of these small plants, Their decomposed bodies and waste products add organic material. We call this organic material humus. Soil is weathered rock with organic material added to it. Topsoil, where plants with roots can grow, is the surface soil we find on the ground. But rich topsoil like humus can take thousands of years to form.
Wind is another cause or agent of weathering. Wind can make sand and other particles airborne, hurling them against natural forms and man-made structures. Assaulted by the wind, rocks are exposed, scratched, pitted, and eventually broken into fragments. In the desert, frequent sandstorms can greatly alter the terrain and any existing structures. And at higher altitudes, winds are a constant force in the wearing down of mountains. Thus far during this program, we've discussed mechanical and chemical weathering as agents of natural changes on the Earth's surface. Now for a review question, go to activity sheet number 1. The Statue of Liberty in New York's harbor is one of our most famous monuments. Periodically, it must be repaired because of damage caused by weathering. What steps can be taken to prevent this damage? Turn off the player to answer the question. Then, turn it back on when you've finished.
Here's the correct answer for the exercise you've just completed. To prevent weathering damage, workers can coat the Statue of Liberty with a protective paint resistant to the weathering process. Such protective paint can also help slow the effects of weathering on bridges and other structures.